TCP Scan, also known as TCP Connect Scan, is the default TCP scan type when SYN scan is not an option. Well, when is the SYN scan not an option? Do you remember the trip of data packet on a DNS query? In that lecture, I said that Layer 3 and Layer 4 packets are managed by the operating system of your device. That means user does not interfere with the TCP three-way handshake. The whole process is managed by the operating system itself. In a SYN scan, we interrupt the three-way handshake and don't send a last ACK packet to complete the handshake. You have to be a privileged user to be able to interrupt the handshake. If you're not a privileged user, you cannot interrupt three-way handshake and cannot perform a SYN scan as well. So instead of writing raw packets as most other scan types do, which needs admin privilege, Nmap asks the underlying operating system to establish a connection with a target machine and port by issuing the native connect system call. So you don't need to be a privileged user to perform TCP connect scans. When SYN scan is available, it is usually a better choice. Nmap has less control over the high-level connect call than with raw packets, making it less efficient. The system call completes connections to open target ports rather than performing the half-open reset that SYN scan does. Not only does this take longer and require more packets to obtain the same information, but target machines are more likely to log the connection, not too stealthy. The steps of TCP Connect Scan is exactly the same as TCP three-way handshake. You send a SYN packet to open a real connection and then wait for a response. A SYN ACK response indicates the port is listening or open, while a RIST reset is indicative of a non-listener. If no response is received after several retransmissions or an ICMP unreachable error is received, the port is marked as filtered. If you receive a SYN ACK from the target system, you send an ACK packet to complete the three-way handshake. Since we have nothing to say at the moment, we send RIST to end the conversation. Let's see what happens under the hood when we perform a TCP scan, and then compare the SYN scan with a TCP scan. Let's perform an Nmap TCP scan in our virtual network first. Go to Kali and open a terminal screen. I want to scan my Metasploitable system. So let's check if the host is up first. I know the IP address of my Metasploitable VM, so type ping 172.16.99.206 and hit enter. Okay, we received response packets. The system is up. Let's create the TCP scan command. Nmap is the command itself. S uppercase T is TCP scan. N is to avoid the DNS resolution. I'd like to see the IP addresses. Uppercase PN is to avoid the host discovery. I already know that the host is up, although you should make it a habit to use PN while you're scanning a single system. Now we have the target IP address 172.16.99.206. And let's keep it fast. Scan for the top 10 ports only. I use top ports parameter for this purpose and hit enter. Here are the states of the top 10 ports of Metasploitable. 7 ports are open and 3 ports are closed. Okay, let's open Wireshark and see what's happening when a TCP scan is performed. So you got to run Wireshark first. Double-click ETH0 to start to listen to that interface. To skip the packets which we're not interested in, I add a filter. I only want to see the traffic for my destination computer, 172.16.99.206. And I want to see the TCP traffic only. Click the blue arrow next to the filter bar to activate the filter. To clear the packets we've already caught, I restart Wireshark packet capturing. Okay, now go to the terminal screen. I'd like to analyze the TCP scan packets for an open port first. I'm going to run the latest Nmap query again, but this time I run the query for port 80 only. Hit enter and run the Nmap query. Yes, the port is open as I remember. It's good to know I'm not losing my memory. Go back to Wireshark. I want to stop Wireshark by clicking the red square at the upper left corner to avoid unwanted packets. Now here we have 3 packets. The first packet is a SYN packet to start the three-way handshake. It's from an arbitrary port of Kali to the 80th port of Metasploitable, the destination system. Second packet is a SYN-ACK sent by the destination system. The third packet is an ACK sent by Kali to complete the TCP three-way handshake. And the fourth packet is a RIST sent by Kali again to end the conversation. Now this time, I want to scan a closed port, for example, port 81. Before running the query, I restart the Wireshark packet capturing to clean its screen by clicking the blue button in the upper left corner. In the terminal screen, I hit Enter to run the query. As you see, port 81 is closed. Now let's look at the Wireshark interface to see what happened when we scan a closed port. The first packet is again a SYN packet to start the three-way handshake. The source system is Kali and the destination system is Metasploitable. The second packet is, for this scan, a RIST packet. Because port 81 is closed, the destination system sent us a RIST packet. So here we have a comparison between SYN-SCAN packets and TCP scan packets for an open port. In SYN-SCAN, Nmap has corrupted the three-way handshake by a RIST packet. In TCP scan, on the other hand, the three-way handshake is completed and the communication is established. So let's see the differences between the SYN-SCAN and the TCP scan in a table that we've only really talked about up to now. Three-way handshake is not completed in SYN-SCAN while it's completed in TCP scan. A RIST packet is sent when a SYN-ACK is received in SYN-SCAN, while an ACK packet is sent in TCP scan. Target machines are more likely to log the connection when the connection is established in TCP scan. No log for SYN-SCANs because three-way handshake is not established. Because the native operating system call is interrupted, SYN-SCAN has to be run by a privileged user. TCP scan uses the system call, so it does not need extra privileges.